Today's video is on integration using residues. In today's video, we are going to evaluate the integral using residues. And in this video, we have to show that integral 0 to 2 pi d theta by a plus b sine theta is equal to 2 pi by root over a square minus b square. Here the condition is a is greater than b is greater than 0. So this is the integration around the unit circle. So let us consider z value as e to the power of I theta. See here, z is equal to, what is e power I theta? E power I theta is nothing but cos theta plus I sin theta. So if I apply mod z on both sides, mod cos theta plus I sin theta. So this will be mod z is equal to, this is root over cos square theta plus sine square theta. So which is equal to 1. So mod z value is equal to 1, which is a unit circle. So as this is a unit circle, so this is a unit circle. And the next thing what I am going to do is, so as I have taken z is equal to e to the power of I theta, z is equal to e power I theta. If I make a derivative on both sides, then dz is equal to e power I theta into I times of d theta. See here, e power I theta is again e power I theta, and for theta this is d theta. So e power I theta is nothing but z. So this is z I into d theta. So I want the value of d theta in order to substitute there. So I am taking d theta value. So d theta will be dz by zi. Clear? So after getting this one, after getting d theta, again I need the value of this one, sine theta. So for substituting the sine theta value, I have to take this one. Sine theta value is equal to, for sine theta, I can write this as e power I theta minus e power minus I theta by 2 into I. So as you know that e power I theta value is z, this can be written as sine theta is equal to z minus z inverse by 2 into I. So 2I. So sine theta value is equal to, sine theta value is equal to z minus 1 by z by 2I. So sine theta is equal to, sine theta is equal to z square minus 1 by, this is 2 into z into I. So I got the value of sine theta value also. So after getting sine theta, d theta, and again mod z is equal to 1. See here, first of all I have taken z is equal to e power I theta, and we got a unit circle here. This is the integration around unit circle, and z is equal to e power I theta. After making derivative on both sides, this is d theta value is equal to dz by zi. See here, here we have to substitute d theta value, and sine theta value here is also z square minus 1 by 2 zi. So after getting all the three values here, the first value here is d theta is equal to, d theta is equal to dz by zi, and sine theta value here is, this value is nothing but z square minus 1 by z square minus 1 by 2zi. So this value is 2zi. Now I have to substitute everything in this. So after substituting here, this value is nothing but integral 0 to 2 pi. This is integral 0 to 2 pi d theta by, this is a plus b into sine theta. So this is nothing but integral 0 to 2 pi. What is d theta? This is dz by zi by, this value is a plus b times of sine theta is nothing but z square minus I by 2z into I. So now this value will become, so this is integral 0 to 2 pi, this is dz by, this value is zi times of. So if I take 2zi LCM, so this will be 2zai plus b into z square minus b. Clear? Now I can cancel this zi and zi, and I am going to send this 2 to the numerator, and this will become integral 0 to 2 pi, integral 0 to 2 pi 2 into dz by, so this value is nothing but bz square plus 2zai minus this value is b. Clear? And after doing this, so this is nothing but integral 0 to 2 pi d theta by this is a plus b into sine theta. Clear? This is integral f of z into dz. Now what is our f of z value? So f of z value is nothing but integral dz. Between that it is f of z value. So f of z value I am taking as this is 2 pi. This value is bz square plus 2zai minus b. So now what we have to do? So in order to find the poles, we have to again equate this denominator to 0. So if I equate the denominator to 0, this will be bz square plus 2zai minus b to 0. So how we have to find the poles? So we have to find the roots for it. See, after equating, so the formula here is minus b plus or minus. So this is minus b plus or minus root over this is b square minus 4ac by 2 into a. So that we'll be getting the z root values. So now if I substitute in place of a, we have 2ai. So z is equal to minus 2ai plus or minus root over minus 2ai whole square minus 4 into a into c. So this is c plus b square by 2 into d. Clear? Now z is equal to minus 2ai plus or minus root over. So this is 2 square, this is 4 a square and I square, this is minus plus this value is 4b square by this value is 2b. And z is equal to minus 2ai plus or minus. So if I take minus 4 common, this will be a square minus b square by this is 2b. Clear? So z is equal to minus 2ai plus or minus, in place of minus I am writing I square, 4 into this is a square minus b square by this is 2b. And see, from the root if I take 4, what will happen? 2. So z value is equal to, see our z value is equal to z is equal to minus 2ai plus or minus this is 2i root over this is a square minus b square by this value is 2b. This value is 2b. Now see, now I can take 2i common. So this value is, if I take 2i common, this will be minus a plus or minus root over this is a square minus b square by this is 2b. And now I can cancel this 2. And see, our z values are nothing but I by b times of minus a plus or minus root over a square minus this is b square. Now we got the two poles. So let the two poles be alpha and beta. Let alpha and beta be the two poles. So alpha can be written as, so alpha value is equal to, our alpha value is, the first thing is minus I by b times of minus a plus root over this is a square minus b square, and beta value is nothing but I by b times of this is minus a minus root over this is a square minus b square. Clear? These two are the roots. Now we have to check whether which root is inside the circle, outside the circle or within the circle. So as it is a unit circle, so here there are two conditions. As it is a unit circle, mod z is equal to 1, and there is a condition from the question here as, see here, from the question it is a is greater than b is greater than 0. So here clearly our a value is greater than 0 and b value is also greater than 0. There is a certain value which is greater than 0. So it might be 1, 2, 3, 4 and so on. So if I take 1, if I take b as 2 or else if I take a as 2, so this is minus 1 and minus 2 which is greater than 1. So it is beyond 1 value. So as this is the circle, as this is 1 minus 1, this is I and this is minus I. this is a circle with center 0 and radius 1. So beta value exceeds, as there are 2 minus, so beta value exceeds and it stays outside the given region. And whereas here minus a plus, so it will be beyond 1. So alpha value will be inside the circle. So I am going to find the residue for the interior poles. For finding the residues of interior poles, see what we have to do. So we have to find the residue. For that I am taking f of z. So what is f of z value? So f of z is nothing but, so here it is, I have equated that to 0 here. So this is 2 by bz square plus 2zai minus b. So our f of z value is 2 by, this is bz square plus 2zai minus b. Clear? See, let me show once again. That is 2 by bz square plus 2zai minus b is our f of z value. From this I am taking b common. See, f of z is equal to, so from this, for my convenience I am taking b common. See here, this will be z square plus 2ai by b into z minus this value is b by b. Now this can be written as 2 by b times of this value is z square minus of minus 2ai by b into z minus 1. And let us see here. So our alpha value here is very clear, alpha. So we got alpha value as, so alpha value is this one and beta value is this one. So if I add up these two, alpha is equal to I by b times of minus a plus root over this is a square minus b square, and beta value is equal to I by b times of this is minus a minus root over a square minus b square. Clear? So if I add these two, alpha plus beta, and see, it will be I by b times of minus a plus root over a square minus b square, and this one minus a minus root over a square minus b square. So if I cancel these two, and I'll be getting minus 2ai by b. See here, minus 2ai by b. So in place of minus 2ai by b, so this value is nothing but alpha plus beta. And next one I am going to multiply this one. So this is 2ai by b, and again I am going to multiply this one. So what is a by b? So if I take I by b common here, this is a plus b into a minus b. So this can be written as a square minus this value is b square. A square minus b square, alpha into beta. So this value is I by b times of this is a square minus a square plus b square. So if I cancel, see here, alpha into beta. What is alpha here? I into b, and here also I into b. So this will be square. So this value is I square is minus 1. This is b square. B square, if I cancel, the value here is minus 1. So alpha beta value I got as minus 1. So alpha plus beta value is minus 2ai. So this is I by b, and alpha beta is equal to minus 1. Clearly I can substitute here. So f of z value is equal to, so f of z value is equal to, this is 2 by b times of this is z square. In place of 2ai by b, I am substituting alpha plus beta, and in place of minus 1 I am writing alpha beta. Clear? And now if I expand, see what happens to this one. So f of z is equal to, this is 2 by b times of this is z square minus, so here there is z here, z alpha minus z beta plus alpha beta. Clear? So this can be written as f of z is equal to, this is 2 by b times of, if I take z common, this will be z minus alpha. If I take minus beta common, this will be z minus alpha again, and therefore f of z is equal to, so f of z is equal to, this is 2 by b times of this is z minus alpha into next one, this is z minus beta. So for this f of z, we have to find the residue at the point z is equal to alpha. So we have to find the residue of f of z at alpha is equal to, so what is our alpha value? Alpha value is nothing but minus I by b. See here, this is minus I by b times of this value is, so plus I by b is equal to minus a plus root over, this is a square minus b square. So this is actually our alpha value. So now we are going to calculate the residue of f of z. So residue of f of z at the interior point z is equal to alpha. Alpha is within the unit circle. Therefore, this value is limit z tends to alpha. This is z minus alpha times of f of z. So here this is limit z tends to alpha. This is z minus alpha into f of z. So what is our f of z here? That is 2 by b times of, this is z minus alpha into z minus beta. Now after cancelling z minus alpha from the numerator and denominator and keeping z as alpha in the rest of the function, this will be 2 by b times of, this is alpha minus beta. So this value is equal to 2 by b times of, so we have to substitute alpha minus beta. So what is our alpha value? Alpha value is nothing but I by b, I minus b times of, this is minus a. So this is minus a plus root over a square minus b square, and this is minus of, this is minus of minus root over beta value is b square. So after taking I by b common, and now this will be, so this is 2 by b times of, this is b by I after sending to the numerator. So this value will be minus a plus root over a square minus b square, and this is minus of minus plus a, and this is minus of minus plus a, this is a square minus b square. So now I can cancel these two, b also got cancelled. This is 2 by I times of, so this value is 2 times of a square minus b square. So even I can cancel this 2 and 2. Therefore, we got the residue value of f of z at interior pole z is equal to alpha is nothing but, see here, this is 1 by I times of root over a square minus b square. So this is our residue value. The residue value is this one for the interior pole z is equal to alpha. Now we have to apply the residue theorem now. After applying the residue theorem, so according to our problem, we got the residue value of f of z at the interior pole z is equal to alpha is nothing but 1 by I times of root over, this is a square minus b square. Now we have to apply, which thing we have to apply? The residue theorem. According to the residue theorem, we have integral f of z dz value is equal to, this is 2 pi I into, this value is sum of the residues, at interior poles. Here the interior pole is z is equal to alpha. So what is our integral? So our integral value is nothing but the question, that is 0 to 2 pi d theta by, this is a plus b into sine theta value is nothing but 2 pi times of the residue value here. The residue value here is 1 by I into, this is root over a square minus b square. So if I cancel this I, so what is our value? This will be integral 0 to 2 pi d theta by, this is a plus b into sine theta value is nothing but 2 pi by root over a square minus b square. So this is what it is asked in the question to show that. So let me explain you once again. The first thing what we have done here is, the question is given as integral 0 to 2 pi d theta by a plus b sine theta is 2 pi by root over a square minus b square. So as it is around, the integration is around the unit circle, we have to put z is equal to e power I theta. So as e to the power of I theta is nothing but cos theta plus I sin theta, mod z value is equal to 1. So this is the unit circle. So this is the region, and z is equal to e power I theta. If you derive on both sides, so we need the value of d theta. Therefore d theta is equal to dz by zi. And again we need the value of sine theta. For sine theta, this is e power I theta minus e power minus I theta by 2i. So e power I theta is nothing but z minus z inverse by 2i. So as we got z value. So all the values are ready here. So d theta value and sine theta value is ready. So we have to substitute in this integral. So d theta I have replaced as dz by zi and sine theta value is this one. So after calculating, we got f of z value as this one. So in order to find the poles, first we have to equate this denominator to 0. After equating denominator to 0 and applying in this formula. So this is the formula. So if I apply this one and calculate, so we got the two roots. So that is I by b into minus a plus or minus root over b square minus a square. So let us consider that alpha beta are the two poles. The first pole is this one and the second pole is this one. So as the region here is a unit circle, so this is a unit circle, 1 minus 1 I minus I. So here if you see that a is greater than 1, so the value here a value is greater than 1, b value is also greater than 1. So here if I take 1 2 or 3 4 or 5 6, so this will be minus 5 minus 6 minus 7, which is beyond this minus 1. So beta value will be outside this contour, and alpha value is within the circle. So we have to consider the poles of, we have to consider the residue value for this. For this there is a modification that I have taken f of z, and for my clear cancellation I have used this one. I have taken b common from this, and after that I have wrote like this minus 1. So alpha beta are known values. So alpha, this value is alpha and this value is beta. I made alpha plus beta, so which is equal to minus 2a I by b, and alpha beta, so if I multiply, the value here is minus 1. So in place of this I have substituted alpha plus beta, and in place of minus 1 this is alpha beta, and therefore I have multiplied and taken, see, multiplied each and every time and taken common. So I got f of z as this one. So now I have to find the residue value at the interior pole. So alpha is the interior pole, and the residue value here, the formula is this one. So z minus alpha into f of z. So f of z is ready here, and after cancelling and substituting z as alpha. So alpha value is also known and beta value is also known, and after cancelling I got the value as 1 by I times of root over a square minus b square. Now applying the residue theorem. So this is the residue theorem, that is 2 pi I into sum of the residues of the interior poles. The interior poles is this one, and after cancelling we got the required solution. Thank you so much for watching. If you really like, what to do, please subscribe and pass it on to your friends, and I'll be uploading many more important questions videos. Please go through that, and thank you so much for staying till the end.